Let us see relation in the set of all integers, that is congruence modulo n relation. Let n be a positive integer. Two integers a and b are said to be congruent modulo n, written as a is congruent to b mod n if n divides difference a minus b. That is, a minus b is multiple of n. Examples are 14 is congruent to 52 mod 2, as difference between 52 and 14 is even number divisible by 2. 14 is not congruent to 51, as the difference between 51 and 14 is odd number and not divisible by 2. The important theorems for arbitrary integers a and b. A is congruent to b modulo n if and only if a and b leave the same non-negative remainder when divided by n. The next theorem gives some properties of equivalence relation modulo n. The first is, it is equivalence relation. A is congruent to a. If a is congruent to b, then b is congruent to a. A is congruent to b, b is congruent to c, implies a is congruent to c. The next two properties are, if a is congruent to b, c is congruent to d, then a plus c is congruent to b plus d, and a into c is congruent to b into d. The last one we can prove using induction. If a is congruent to b mod n, then for any positive integer k, a raised to k is congruent to b raised to k mod n. Now, few examples. 23, if I divide 23 by 8, 8 into 2 is 16, and then the remainder is 7. So, we write 23 is congruent to 7 modulo 8. Similarly, 43, if I divide by 8, for 8 into 5 is 40, remainder is 3. So, 43 is congruent to 3 mod 8. So, the product of 23 and 43 will be congruent to product of 7 into 3, that is 21, and further 21 is congruent to 5. Hence, we get 23 into 43 is congruent to 5 mod 8. The second problem. Find the remainder when 5555 raised to 2222 is divided by 7. Now this is very big number. So first we know that 5555 when we divide by 7, the remainder is 4. So I can reduce this to 4 raised to 2222 modulo 7. So now we deal with a little smaller number. Further, we observe that 4 cube is 64 and 63 comes in the table of 7. So 64 is congruent to 1 mod 7. So now to reduce this 4 raised to 2222, what we will do? We will use this power 3. So first this 2222, when I divide by 3, the remainder is 2, and now 4 raised to 2222 I can write down as 4 raised to 3 into 740 plus 2. That is using laws of indices, it is 4 raised to 3 raised to 740, and you will get 4 square. So I can easily, for 4 raised to 3 I can substitute 1, and 4 square 16, and further this 16 modulo 7, that is 7 into 2 is 14, so it will reduce to 2. Thus 2 is the remainder when 5555 raised to 2222 is divided by 7. Now exercise, you need to complete this at home. Show that the remainder when 2222 raised to 5555 is divided by 7 is 5. Now using these two things, we can solve the following problem. Show that 7 divides this number, and how to I will use which we have already proved, that 4 times 5 raised to 4 times 2 is congruent to 2. and 4 times 2 raised to 4 times 5 is congruent to 5. So if I add these two numbers, it is addition of 2 and 5, so it is congruent to 7. And 7, when I divide 7 by 7, the remainder is 0. So since remainder is 0, I can write down 7 divides this. This completes this problem. Thank you.